So as we move on to number 3 and number 4, we're going to notice that again, it is just simplifying. Now in this case, when I'm looking at number 3, I don't have any more rational exponents. I have only whole numbers. I have as my exponents. I have 0, -3, 5, and 4. I have to take into account also I have these coefficients that are in front of my variables, the 5 and the 3. So what I'm going to do is take those coefficients out front first, and I'm going to multiply them. And then I'm going to put my x's next to each other, x to the 0 times x to the 5th, and then I'm going to put my y's, y to the -3rd times y to the 4th. I can do this because everything that is going on in this previous problem is all multiplication. Anytime we have multiplication, it is commutative, which means it can move around. Even if the parentheses are there, it's associative and commutative, I can move around what parts are associated with what. This is only because every operation is multiplication. So now once I do this, I'm going to simplify each of my parts. I can multiply 5 times 3, and I'm going to get 15. In the cases of the x's, I have 2 x's, so that means I have to add the numerator, or add the exponents, which means I'm going to be adding 0 plus 5. I'm going to have to do the same thing with the y's, -3 plus 4. So my final simplified answer is 15, x to the 5th, y to the 1st. Now you don't have to write the 1, but I did just to kind of show it. Number 4 is going to follow a very similar path. Again, I am simplifying. And again, similar to how it was in number 3, and what's different between 1 and 2 is that all of my exponents are whole numbers. Because of this, I'm just going to simplify the various parts. Now division isn't commutative, but what the nice thing about the division is I have everything lined up very nicely. I could do 12 divided by 3, and 12 divided by 3 is 4. Now up here with the variables with the exponents, I have to take the numerator exponent 4 and subtract it from the denominator exponent 10, and the same thing with the b to the 7th minus the 1. So what we get here is 4b to the -6th, I'm sorry, not b to the -6th, and mistakes happen. It's a to the -6th and b to the 6th. Now we could leave it like this, but since we're simplifying, we're going to assume no negative exponents. Well, 4 is okay because it's a positive exponent of 1, and b to the 6th is okay because it is also a positive. So that means I get 4b to the 6th. However, the a is a negative exponent, which means it needs to go into the denominator a to the 6th. This would be our simplified expression with no negative exponent.